So let's take a look at our problem of the day. I see, you see, we all see that it says write the equation in slope-intercept form of the line perpendicular to the line 4x plus 3y equals 6. And we got a big stipulation here at the end, passing through the point -4, 7. So again, we're looking for the equation in slope-intercept form. By the way, that's y equals mx plus b of the line perpendicular to the line 4x plus 3y equals 6. By the way, that is not slope-intercept form. It's standard form. We're going to work with that a little bit. And we're going to pass it through that point, -4, 7. So let's take a look at it here. Let's see what happens. And notice I kind of left us a little bit on the fringe here. I got us through the equation in slope-intercept form of the line perpendicular to the line, but it didn't specify where it's going to go. So why we want to do that? And I believe it was going to be passing through that good old point. Let me get it right here. -4 and 7. Director Connor, am I correct on that? Is that right? Okay. And what we need to do, it would be nice to get this thing into slope-intercept form. So guess what? We can figure out what slope are we talking about. Now there's an important word here. We'll deal with it. But right now, let's work on that slope-intercept form, and let's work on this line right here. That's where we start. And eventually, we'll bring in the -4 and the 7 together. So this one's got a little complex, but when the solution comes out, you go like, well, that's not so bad. It really isn't. So let's start off, first of all, with our 4x plus 3y equals 6 part. Now, that's important to us because we're going to have to get the slope from that. Intercept comes another place, all right? But what we're looking at is the y equals mx part, all right? If we can get the slope here, then we can deal with perpendicular. You say, really? Yes, really, definitely, definitely. Because this guy is going to give us an x and a y, but not quite yet, all right? If you put that -4 and that 7 in there, probably won't work, all right? It probably will not give us an answer we're looking for, but that's okay. That's not what we're dealing with. We're dealing with a different line than this to get through that -4 and 7. Just FYI. Now, again, let's get this thing by itself. I hope some of you have already gotten a head start on me here. And it looks like we are going to have, say goodbye to those x's because there's a positive 4x. We're going to subtract 4x. Always be sure if you do it to the left, you got to do it to the right. Don't forget that. So here we go. -4x and add 6. Folks, do not say 6 minus 4 and gives you 2. Doesn't work there. This has an x, 6 does not. So we've got to leave them separated with a plus sign because it is a positive 6. It is a -4x. So I put them in that order simply because we're looking for slope-intercept, right? So let's now divide everything through by 3 because, as I said, we want y by itself. That's what slope-intercept is. Something like y equals mx plus b. We always use that formula. And somebody's wondering, what does that mean? M is the slope, b is the y-intercept, and the x and the y can be whatever they want to be as long as they make it a true statement. So put a 3 and a 3 in there. And we're going to divide through, that division property of equality running through for us there. And if you'll drop my lower third out there just a little bit, go ahead and give us a call. So -4/3 x and plus 2, there we have it. And that's not the equation that we're looking for per se. But it does give us one important ingredient. Right there is our slope. Now, let's talk perpendicular. What happens with slopes that are perpendicular? You got two lines together. Now, if they're parallel, they do the same. These aren't parallel. This is the other P word, as we call it, all right? Perpendicular. That means they've got to come in as 90-degree angles. They make right angles when they intersect. These are two lines that are going to cross. And they're not going to cross at this point. Don't get that in your mind yet. But the one we look for is going to contain that point in just a second. But what about the slopes? That's what we're asking about. That's where the question is. Opposite reciprocals. And the opposite reciprocal of -4/3 is 3/4. So that's where we're going to go. We're going to use the slope of 3/4. All right, and that looks good. And then we're going to also bring our little -4/7 into the game. Now we're working. Now we're going somewhere. I think we did one like this in another show, and I used just the y equals mx plus b. I want to use point slope with you today. It's a different approach, a little different approach, but it's still quite legal. Everything's legal, right? Well, as long as if I use it here, it's going to be a legally trusted way. We call it point slope because we've got a slope, we've got a point. So we're going to play it out. And here's the formula. It basically says we take the y in general terms and subtract our one y coordinate we have. Well, that's going to be a 7 in just a second. And then we're going to say m times the x minus the x coordinate that we have been given, all right? In this case, you see the -4 and the 7. They're going in here, and 2/3, did I say? No, 3/4. Whew. I tell you what, it can be a rough day at times, can't it? So let's put our numbers in here. We know our y1, there it is, there's y1, and there's x1. So it's all formulaic. It's all using this grand formula we call the multipurpose formula. We'll put a 7 right there. It equals to 3/4 times x minus that -4. And look where it's going. Notice I said a -4 minus a -4. Watch out, don't put -4 there. That can be a nice little careless mistake that some folks make. We're basically saying we're going to go positives on those, all right? We're going to add the opposite, which basically means we're saying x plus a +4. At this point, it's time to distribute. And I like this number, 3/4 and 4, because they're going to cancel out beautifully when they distribute through. We're going to have 3/4 x, which is great. That's important to us because we know we have to keep that slope of 3/4. So that's a good sign. We have +3, and over here we got y minus 7. Now all that's left to do is let's move that 7 over here. We're going to add 7 to both sides, or add it to that 3 out there. And that's going to leave us with y equals, I'm about out of room, folks, sorry about that, and x plus 10. And there, that seems to be what we're looking for. Now, let's take something back in here. All right, let's go back and check something on this. You know, does that point work here? Well, put a -4 in there. Do you get 7? Yes, you do. So that's a point on that line. Remember, it didn't matter about this one we started with. But let's do a quick graph for a moment on this, and then we'll get you on to the rest of the show here. Let's go to our y equals real quickly here, and let's put in 3/4. Again, easy way to check. That's 3/4 means 3 divided by 4. Put our x on there, and we had a plus 10. That was our new line we found, all right? It's going to be in blue. Keep that in mind. Our old line we had was -4/3. So 4 divided by 3. Put a little x on there. And we added 2 to that. And again, the +2 is a kind of immaterial on this, but it's what we had, so we'll use it. So let's run it through there. And we'll graph. And here we go. I hope this comes out squared out. Usually we leave it in that form. Yep, there it is. By the way, you have to do a zoom 5 if yours is not working right. Zoom 6 will get you a little lopsided, but zoom 5 squares out the page. Notice that beautiful right angle right there. That's what happens, 90-degree angle formed there. And we were on the blue one, I believe, was it not? Well, we'll find out. Let's see, put a trace on that. We'll find out. That's the one we're looking for. Put in that -4 and see if it doesn't work. For those of you just skeptical out there. Do we get a 7? Will we get a 7? Drum roll. We got a 7. And folks, that's a solution of it graphically also to see how that works. So have a good time with that one. I like that problem. I like that problem. And you know, you could have done that with graphicing. You didn't necessarily have to work it out all the way through here. But if you don't have any graph paper, you don't have the grapher in front of you, this is a great way to go. And it's pretty easy. Works out very nicely. Slope-intercept form, y equals mx plus b. And that, my friends, is your problem today.